Great. Thanks a lot for the introduction, and I'm very excited to be here today and share some of our recent works on large language models and alignment. So thanks a lot that Tang has already set up the stage. So we covered what is this large language models and how they're trained. So here the main point is once we train a language model to predict the next word, which basically generates the most likely continuations given context, it is not necessarily a good assistant. For example, here, if the user asks, what is the capital of Vietnam? A good language model could auto-complete that into a multiple choice question. Now, if you think about what are the examples in the pre-training data, this is a very reasonable continuation, but it's not what the user would like to see. And similarly, the model could have reasonable continuations given a context. But again, it might be overly stereotypical or even contains hallucinations. So these are all problems we would like to fix in an additional process. So that is the goal of alignment, where we want to align the model with the developer's intent of building a good assistant to the users. And obviously from the example, we see that the language models have learned lots of knowledge and acquired capabilities through pre-training. But there's no supervision on what is the right thing to do or the expected behavior when we use that as an assistant. So here we need some additional human supervision to align the model, either by directly demonstrating what is the correct response or to tell the model which of the responses is better. So I don't want to go into the detail of these approaches, but the main point is that we need supervision to tell the model what is the desired behavior here. So in this talk, I want to go through two of our recent projects. The first is fine-tuning or aligning the language model to be more truthful or factual. And then in the second case, we'll look at what is the impact of co-writing with language model. And through these two specific projects, I hope to try to answer some broader questions on alignment. So first, what is the model really learning during alignment compared to the pre-training stage? And second, whether there is some unintended effect when we now align the model with human feedback. Okay, let's dive into the first part on truthfulness. So we know that these models are trained on internet scale data. And on the internet, there are both factual information about the world, and there are also misinformation. And when we ask the model to try to predict next word given this data, the model will acquire both the correct information and the incorrect information. And in this recent work by Lin et al., they showed that these larger models are actually better at fitting some falsehoods in the data. So if you look at the bottom figure, where we test these models standard QA benchmarks, where you ask questions like, Miami Beach in Florida borders which ocean? The model can give you a correct answer. And in fact, as we increase the scale of the model, the accuracy also improves. But then if we switch to questions where there are potential misleading information in the pre-training data, such as what happens if you crack your knuckles a lot, then again, if we just look at the blue bars that's comparing GPT-3 models of different sizes, the larger models actually performs much worse in these cases. And the reason is that as the model size increases, it also becomes better at fitting this misinformation on the long tail of the pre-training distribution, which is obviously undesirable. So now, what are our reactions to this phenomenon? I think in the community there are two views. The first view is that there's nothing surprising. So of course, these models do not know anything about truth because they're not grounded in the world. They cannot interact with the real world. They're just trying to spit out something that's reasonable, which could be untruthful. But from a different perspective, people also showed evidence that you can actually predict whether a statement is correct or not by looking at the model's internal activations. And then many people in the safety community raise this argument that these models actually know what is truth internally, but they choose not to generate that, which is a dishonesty problem, and that has a big safety concern. So part of the goal of our project here is to try to have a more clear picture on which of these arguments more accurately describes what's going on in these models. So let's think about how the language model would behave when they're given conflicting data. So suppose we ask the model this question: is there any relation between blood type and personality? And maybe in your data, 80% of the text suggests that the answer is no, and then the other 20% suggests the answer is yes. So how should the model answer? From the classic language model perspective, the model will probably just give you the most frequent answer. So as Tom was showing, it's just predicting the probability of the next word. So this prediction is not concerned with whether the answer is true or not. But at the same time, from our experience using these ChatGPT models, we also see that the model's answer depends a lot on how you ask the question or how you write the prompt. So if instead we write the question as, what personality does someone with type A blood have, which have this implicit assumption that there is some relation between blood type and personality, and then the model could give you a false answer. So what is going on here? It suggests that language model does not only model which answer is more likely, but it also has to model when the answer is likely to be truthful or untruthful given some context in order to further drive down the perplexity. So in this case, after reading the question, the model could infer that the person who could have produced this question must have this belief that blood type influences personality. And then a continuation from that question would be generated by the same agent, so it's better to produce something that is consistent with this false belief. Okay, so how do we know whether the model is actually doing this inference while processing the question? Here we did a very simple verification experiment. So we take questions from Truthful QA, which are a curated question that could have potentially misleading answers in the pre-training data. And we give this answer to the alpaca model and obtain the answers. So the alpaca model would give us embeddings of the questions. And also, we could evaluate whether the generated answers are correct or not. And then remember that our hypothesis, the model will be trying to infer whether the answer is going to be truthful or untruthful while it is reading the question. And to verify that, we basically train a simple linear model that takes in the embedding of the question and predicts whether the answer is going to be truthful or not. So note that here, the input to this probe does not contain the answer. So it's only the question, and we want model to predict its own future behavior. And here we see that, so in this figure, the x-axis is the layer the embedding is coming from, and the y-axis is the probing accuracy, or actually F1 score. So here we see that even from the very early layers, we can predict whether the answer is going to be truthful or not before the model has generated that. And the performance is much better than the random guessing baseline. And in addition, if we take embeddings of at different positions of the question, we can see that the model's prediction of the truthfulness of the answer also increases. So this suggests that while processing the question, the model is actively trying to infer whether it should generate a truthful or untruthful answer. Okay, so why is this surprising? So if we're just predicting the future content the model will generate, that is not very surprising because that's what the embedding is supposed to do. But here, how would the model know that which answers are truthful, which are not truthful? And our hypothesis here is that during pre-training, we have this noisy data set that is generated by different agents or different sources. Some sources are more truthful than others. And the interesting in the data is that the truthful sources would share some common features in their generations. Perhaps they use more formal styles, or they generate more consistent claims. And the model can use these common features to cluster the truthful generations and untruthful generations. So this clustering really allows the language model to distinguish the truthful text from the untruthful text. That's why we can probe in the internal activation whether the answer is going to be truthful or not. And the other really nice thing about this clustering is that we can then fine-tune the model to generalize this truthful behavior. In particular, we fine-tune Alpaca, the truthful QA dataset. We have two settings where you can either fine-tune the model to generate a truthful answer or fine-tune the model to generate a more untruthful answer. And the key thing here is that when we test the model on the held-out set, there's no transfer of knowledge from the training to the test set, meaning that if the model has learned personality has no relation with blood type, it doesn't really help the model to know that the weather in a single day does not tell us much about global warming. So without this knowledge generation that is common in supervised learning, how would the model then generalize this truthful behavior? And here's the result. So we see that, so we test data on both the truthful QA dataset and out-of-distribution dataset from Big Bench. And without fine-tuning, the model is not very truthful. The accuracy is only about 30%. But with either truthful or untruthful fine-tuning, it can successfully steer the model towards generating more truthful or more untruthful answer. So it clearly shows that the model can directly learn to behave in a more truthful way as opposed to learning the specific correct answers of each question. And we also tested on a control dataset where we train the model on the standard QA dataset, and it doesn't have much influence on the performance, which suggests that the increase or decrease of the performance is not due to model just learning to learning better question answering formats. All right, so going back to the more high-level question of what the model is really learning during alignment compared to pre-training, based on these results, we see that the model must have learned both the correct and incorrect answers during pre-training. And that's why even without direct knowledge transfer, it is able to produce the correct answer. And during fine-tuning, essentially what's happening is that giving a question with, that is potentially linked to the untruthful persona, the model just needs to remap or reconnect that internally to the truthful persona. So it doesn't require lots of training data and doesn't really require this in-distribution training data to become more truthful. All right, so to quickly summarize this part, here we want to understand how the model could learn truthfulness during pre-training even without explicit labels. And the main hypothesis is that the data is generated by some truthful and untruthful agents or sources. And these different agents would share commonalities or common features. And the model would actually use these features to cluster the truthful statement and untruthful statements. And because of this clustering, we are able to probe truthfulness of the answer before it is even generated from the model, which is potentially useful for abstention. And also, from alignment perspective, we can fine-tune on a set of facts to improve truthfulness on unseen topics. And we don't need a lot of data to achieve this improvement. All right. Now, going back to our speculation, where the first argument is the model knows nothing about truth. And from these results, we see that this is not accurate because at least the model knows what is truthful. The model knows that the true answers are different from the untruthful answers. So it knows this clustering. But then the question is whether the models can robustly separate truth from falsehood. So we mentioned that there are commonalities among true statements, but we didn't really talk about what are the features the model are using to clustering truth from falsehoods, because there could be spurious features the model is using. So this would require further investigation. And as for the second argument, from the safety perspective, which says that the model knows what is true internally, but it doesn't generate it. That's why the model is dishonest. And we can see this is also not an accurate description, because what we see is that this model knows that there are multiple answers or multiple clusters of answers, but it doesn't really know which one is the truth. That's why we need this additional alignment process to steer the model towards the truthful answers. All right, so now I'm going to switch gears and talk about the second topic, where we look at what happens when people co-write with these language models. So writing assistants are prevalent nowadays. And probably all of us are using ChatGPT in our writings. And we see that now we have this single or a few model that is influencing a group of people's writing with different goals and preferences and backgrounds. So one concern here is that it might cause this homogenization among people's writing, meaning that different users will now write more similarly to each other. And to some extent, this is not really a new phenomenon, because even when we're using spelling or grammar correction tools that can already bias people's writing to be more similar to each other, especially for non-native English speakers. But now I think the concern is that once we have this more powerful and more closely integrated writing assistants, that further bias the content or opinions of people's writing to be more close to each other. And as a result, this would reduce the diversity of the content generated by a group of people. So to understand to what extent this is happening, and we run these controlled experiments, and our interface is built on top of this co-author interface developed by Lee et al., where the user can query the model to produce a continuation or multiple continuations, and then the author can choose one of them and continue to edit their writing on top of that. And we have the three setups here. Each user would participate in all of those three settings. They write an essay on their own, write with GPT-3, which is the base language model, or write with Instruct-GPT, which is the aligned language model, or a language model that's tuned on human feedback. And of course, when they write this in different settings, they're writing on different topics. And we were able to get reasonable interaction between the user and the model. In particular, for each essay, which is around 400 words, people query the model about 9 times. And the model suggestions are accepted about 70% of the times. And if you look at the final completed essay, there are about 1/3 text that is contributed by the model. So then our goal here is to measure to what extent is homogenization happening. So how do we measure homogenization? And by definition, this is basically the similarity between two documents written by two different users. So we could use any similarity metric, but here recall that in particular we don't really want to focus on the superficial similarity between text, but instead we want to look at whether the content becomes more similar. So to compare the contents of two documents, we first map these to a set of key points that represents the gist of the content using ChatGPT. So instead of comparing this long raw text, we would compare these more structured key points from the documents. Okay, and then we can use the standard similarity metric to measure similarities of two documents. And here, we show the homogenization score across different topics in different setups. So we can just focus on the leftmost column where the score is averaged over different topics. So interestingly, we see that when users are writing with the base language model GPT-3, there's no significant change compared to when they're writing alone. However, when the user now starts to write with instructed GPT or the aligned language model, it improves the homogenization or similarity between two people's writing. And next, we also look at its impact on overall diversity, where diversity is defined by the number of unique key points divided by the total number of key points. And here, the intuition is that we want to see if the number of arguments or points people are making would be reduced because of the influence of these language models. And to measure whether two key points are equivalent to each other, we use agglomerative clustering, so then key points that are put into one cluster would be equivalent to each other. And what we see is that across all the different thresholds for clustering, writing with instructed GPT consistently reduce the fraction of unique key points, meaning that people are making fewer arguments when they're writing, or fewer unique arguments when they're writing with these aligned language models. And then we further looked into what is really repeated when people are writing with language models. So on the right, you see that when they're writing alone, the repetitions are mostly on the common phrases, like on the other hand, or the most important thing, etc. But when they're writing with language models, the repetitions are more focused on this topic-specific or argument-specific phrases, like focus on animal welfare or selfish to pursue risky sports. So the models output are actually influencing people's arguments, even though they have full freedom to edit what the model has generated or suggested. All right, and the main reason here is that when we look at the output from the instructed GPT, they're less diverse. And when these suggestions are incorporated into the text, they tend to have much larger probability on the most frequent n-grams. So I think this is also connected to other related works that more directly studies whether large language models represent diverse opinions among humans. So in these papers, they look at the model's outputs, these contentious questions such as whether we should prefer a good democracy or a strong economy. And even though humans from different groups would have very diverse opinions on this question, when we look at the language model, in particular the aligned language model based on human feedback, it is overly aligned with answers from a particular group. So this is another similar observation that is same as what we saw in the co-writing setting, where the aligned language model becomes less diverse, and this could actually impact the content people generate. Okay, so to conclude from these two projects, we see that the good news here is language models can potentially learn more abstract concepts like truthfulness during pre-training. And during alignment stage, we only need to steer these models towards the desired behavior, which suggests that we should not need a lot of data for alignment, and the more efficient, more fine-grained control is possible as a post-processing stage. But on the other hand, the bad news we saw in the second project is that there are a lot of trade-offs and design choices to make in the alignment process in terms of what kind of feedback do we get, what should be the annotator pool, and what prompts or questions should we present to these annotators. And right now, the process is very ad hoc and somewhat in a black box way. So I think in future it's very important to think about the more principled framework for collect and modeling the diverse preferences to align these language models. And with that, I would like to conclude the talk here and thank all the students and collaborators who actually done the work. Thank you.
Thank you very much, Ms. Cook, for your insightful sharings, and we look forward to hearing more exciting news and announcements from you. Thank you.